All right, great. So, welcome, team. I hope you all had a good break. Um, so, before we went on the break, we discussed the foundation of GenAI, right? So, the platform, the tools, introduction to GenAI, what are LLMs different? Just kind of let me give a recap, quick recap. So, what are the different types of LLMs in the sense what is an LLM? How does it work? Um, what are embeddings, embedding models, right? The LLM models that used for embeddings. What is a prompt engineering? What are the different techniques you should use for prompt engineering, like zero shot, few shot learning, React, which is reasoning and act, or chain of thought, basically, how it works in the LLM, embeddings and vector databases. How do you store, generate embeddings? How do you store in the vector database? What are different types of vector databases? We worked with FireDB, Chroma, Pinecone, different vector databases. Semantic search. What are the techniques like? You know cosine search and cosine similarity search, and then the distance, list distance, square distance, different techniques that we use for doing the semantic search on the vector databases. Building RAG applications to overcome the limitations of LLMs, basically to augment the information that an LLM has access to the information by providing our own personal information, personal in the sense the organization data or the data, private data that we have, so that the LLM can use that data to answer the questions, basically mostly in the use cases like chatbots or legal research, summarization of the documents, things like that. So after the RAG, so that forms the basic, that forms the foundation. We also looked at building RAG applications using code, different frameworks like LangChain. We explored LangChain, how you can create a prompt, use an LLM, and then chain everything to retrieve the data from vector databases, and then add it to a prompt template and send it to LLM and retrieve the response and all of that. So using LangChain library, using Google Colab Python, simple Python, we built the applications. Now, and we also explored no code platforms. We explored Langflow, we explored Amazon Bedrock, right? AWS Bedrock. So in the Bedrock, we built knowledge base from the documents that were there in the AWS S3. So whatever, it's like library. So whatever documents are in the S3, we created a knowledge base just like a library and used that knowledge base in the visual UI on the Amazon flows, Bedrock flows, basically to connect that library and then build a RAG application. So we will review it again when and Langflow, basically. Langflow is from DataStax. I think I have just forwarded or pinged you some message yesterday. So the Langflow that we were exploring from the company called DataStax, Langflow and AstraDB, which is a vector database, both from Langstacks, is now merging or bought by IBM. So it's going to be part of IBM, right? So all the AI companies, the big companies, want to have a foothold in the AI landscape. So everybody is trying to have a decent or well-established AI company to be part of their future journey to growth. Salesforce has bought over Informatica for almost like $8 billion or something. So now Salesforce and Informatica are merging. IBM has bought Langstacks. So basically, DataStax, sorry, not Langstacks. So basically, yeah, the future is all about mostly about AI and the AI agents in the sense. There are some, the adoption is initially was low, but now it's picking up, as the trust builds, as the LLMs become more mature in terms of handling the hallucinations mainly, and predictability, and the uh, security of these LLMs and the frameworks that come in. There's a whole lot of new kind of architectures that are being built, right? So just like it's a shift in the architectures. So from the desktop world to two-tier to three-tier to internet to web applications to cloud services to compute cloud computing to microservices to containerization and orchestration with the Kubernetes and Docker. So from there, so that's the shift, the evolution. Now the AI, ML, machine learning, traditional machine learning models on the analytics platforms like Databricks and data warehousing is Snowflake. So the next advancement in the AI for extension of ML using ML, traditional ML, is the generative AI. Now everybody is trying to adapt and figure out what is the ROI, how it can be used, what are the different use cases it can be more beneficial, and how we can and how it can be improved, to be adaptable, to be trusted, kind of a thing. So the major thing these days talk about is agents, right? So everybody, the Satya Nadella, the Mark Zuckerberg, or Sundar Pichai, Jensen from Nvidia. So all of these people talk about, or the Elon Musk. They all talk about agents. So the future is all going to be agents. A lot of people. So recently, Satya Nadella said about 30% of the code in Microsoft is being written by the AI, right? So it's generating the code, it's writing the code. 30% of the uh, working code, like productionable code, is about 30%, but overall it's like almost like 60 to 70% of the code is being written by AI. So that's how powerful the impact of AI is. And so the future, it says, like, so it'll all be agents, right? So there will not be any not it's not be, sorry, I take my word back. Mostly there will be two kind of engineers. So there'll be a human engineer, there'll be an AI engineer. So the counterpart, the human engineer. So we going forward, so one of these kind of predictions, or the vision is, there will be a lot of AI agents reporting to a human agent. Basically, one person will be handling departments. Each department can be just an agent or a group of agents working together to handle a complete department, right? Like HR department, for example. So all of the HR functions can be automated using AI agents, workflows, agents, and a very few AI human engineers, sorry, not AI, very few human engineers overseeing those agents, and human intervention only when needed, kind of a thing. So they said, like, future will be millions or billions of different AI agents. So we will see enterprises, or we are already seeing two kinds of businesses. One is implementing those solutions, the AI solutions on the platforms, automating the workflows for businesses. The other one is like creating those products or agents, owning the agents, and selling those agents, kind of thing. So this will be two kinds of new businesses that will be coming in the future, or it's already here. Sorry, already here. So that's how the focus is on AI agents. So what we will understand, we'll start about is, so what is an AI agent? What does it do? Right? And what are the different frameworks to build the agents? Right? So that we will explore. Okay. So that's the introduction that I want to give about the AI agents. So do you have any questions in general, like what you have heard about, lot about the uh, impact of agents on the workforce, on the engineers, or in the businesses? So do you have any questions or comments, observations? Guys, speak up. Do you have anybody? Any questions, observations, comments? Am I audible? Are you guys able to hear me?
Good morning,
Uh,
all.
yes,
Okay. Okay.
yes, you're audible.
Okay. Yeah,
I
Hari.
was no, I was gonna ask after we finish all the are we gonna cover LLM ops also, or just the
Yeah, we will also do LLM ops part of it.
okay?
Yes. So this, I mean, if you look at the curriculum, we already have Langsmith and the Langser. Okay. So we will touch upon that as well. Yes. And the protocols. So if we have time to do some bonus sessions, we'll do some protocols as well. We'll discuss. Okay. All right. So what is an agent? So we have done, so we kind of looked at the RAG applications, we kind of looked at the LLMs, right? So what a simple basic definition of an agent, just to visualize, is an agent is a set of a body or an entity with an brain, LLM as brain, right? So each agent will have an LLM as a brain that will, you know, do the work, and then it has few other components. Like it has a goal, it has a role. So an agent plays a role. It's kind of a persona, right? You give it a role to play, and it has a goal to achieve, playing that role. It has some tools, the means to achieve that goal. Okay. And then it can do kind of planning, retrieving, decision making, autonomous, in order to achieve that goal or that task using the tools it has. So that's the basic definition of agent. Okay. So it refers to AI systems designed to exhibit autonomy. So it can make decisions. It's not a fixed loop. It's very indeterministic. It can make decisions based on the inputs. It's not like the program. That's the main difference here. Basic differences. Any program you write, any logic you write, there is always a conditions, right? So you write if else conditions or evaluate. You evaluate if this happens, you do this. So you kind of give it. So every time that happens, it will do the same. It will follow the same branch or do the same kind of operations, follow that path, execution path. But here, we are not sure what kind of logic, basically what kind of questions come in, right? So we cannot code for every possible question. So that autonomy is given to the agent to understand based on the question, based on the task, what path it has to take. Okay, what actions it has to execute. So that is the autonomy given to the agent. That's the core of all agentic, all agents. That's the main core. You are not influencing the decision making. It's autonomous. The agent is taking that decision to do. That's also a challenge because you don't have control over what decision the agent takes based on the input. You have to have a lot of training and understanding to the agent, saying that hey, in these scenarios this is what it does, so this is how it should behave, kind of a thing, right? So it's both, it has autonomy, it can do automatically, it's a great thing, and it also comes with its own challenges. Now it takes proactive decision making. So it makes its own decisions based on what it has to do, and a goal directed behavior to solve complex problems. You give it a complex problem, right? Say, for example, what are the best stocks to invest? It's just one line. Okay. Now you if you ask a question to an LLM, it can give you some lot of, text, best stocks, whatever is written in the articles or in the news in the past. It has read about, understood about. It will give you all of that, but that does not help you because you wanted to invest in the stocks today. Okay, so you have to understand what are the top performing um, stocks today, right? So that's the goal. Now this is the scenario. The scenario is, the task is to identify the top performing um, stocks to invest in. Okay, for example, so that is the good. Now, who do you think is the best person to go to? If I have that question, who do I go to? Do I go to a uh, data analyst, or do I go to a attorney, or do I go to a professor or researcher, or do I go to a healthcare assistant? Who do I go to for this scenario? Anybody?
So what was the scenario again, Harun? Sorry.
I want to invest in the best performing stocks today. I want to know what are the best performing stocks to invest in.
Oh, okay. It's just
It's simple. Who do
the
you go to? Who do you want to
yeah,
go and
Yahoo Finance, Bloomberg Finance to look.
No, let's not talk about the tools or whatever. Yeah, so those are the resources. Okay.
Mm-hmm.
If you have to go to a talk, you have to pick up a phone and call somebody, or you have to consult somebody. So who do you go to?
Oh, you mean the advisor,
Yeah,
like
yeah. Would
financial?
you go to a doctor?
No,
So who do you go to?
yeah, financial advisor, whoever.
Right? Yeah,
Yeah.
exactly. So you go to a financial advisor, financial analyst, whoever it is, stock market analyst, stock market advisor, whoever it is. So you know a specific role or a specific persona to go to, right? So you have financial advisor. Okay. So that's the role an agent has to play. That's the ideal. Now, even if you go to a doctor, right? Let's say a doctor, and you ask him, he would still give you advice. He would say, hey, what is stocks? I don't know stocks, right? So any doctor you talk to, they must be already also investing in stock. They must also be knowing some knowledge about the stocks. They are reading news. Yeah, yeah, Apple is performing very good, or some stock has doubled, like Nvidia. So if you go to a doctor, he can tell you Nvidia is the best stock, right? He can also tell you, but his knowledge is generic, right? He's limited to what is known in the market or what he has read about things. It's not specific. Okay. So if you go to a financial advisor, he will give you Nvidia is okay, but he would also give you why Nvidia, what happened with the stock, why it has grown, what is the future of that stock, is it saturated or it will grow at the same rate or not, and why does he think, what are the factors, like what is the market conditions, what are the different variables that impact those stocks, and why he thinks is that best to invest in. Apart from Nvidia, he can also tell you what are the other stocks, what is the past history, and if they have grown so much, why they have grown so much, what caused them, what is the shift, what shift in the market, right? So all of those things is the specialized knowledge of that role. So in the same context, if you just ask an LLM, okay, let's like a doctor or professor, any LLM will give you some advice, generic advice, which everybody knows. But if you want to go to a specialist, right? So that will be the role that an agent has to play to give you this. It will give you this more specific knowledge. Okay. Now, so that's the role. Now we have the goal. The goal is to identify the best performing stocks to invest in. So that's the goal. You have the role. You're going to financial advisor, right? So what else do you need, right? So if you have a financial advisor, he has to analyze. So to analyze, what does he need? He needs the tools, right? So he has to look at various data, markets, and analyze that data, some models, and all of that. So all of those are the tools that enable him to do that analysis. So similarly, the agent will also be provided, should also be provided with some tools to execute that, to reach that goal, to perform that task, complete the task, to reach that goal. So when we are talking in this, like Hari earlier touched upon, Yahoo Finance is a resource, right? So you will have a tool that the agent can use, access the Yahoo Finance, okay, and get information from the Yahoo Finance, whatever it is asking. Now, a financial advisor will know what to ask, right? Where to go. The same thing, the agent should know what to ask or what information it should get from the Yahoo Finance. Plus, what are the latest market news? So again, it has to have a tool to go onto the internet. So remember, LLMs do not have ability to answer you in the current state. They only have knowledge on the cutoff date, to which date, till which date the particular model was trained and released. So once it is released, it does not have latest current information. It has to depend on the tools to connect to the internet and get that information for you. So web search is also another tool. So not just web search, there are different providers. Example, Google gives you different APIs like Google SERP API, Google Search API. There is a DuckDuckGo search. There is Tavili search. So all of these tools help you to help the agents to connect to the web, internet, to search the data. I mean, you can also implement that in Python. Even if you're writing just a Python script, you can use these tools to connect to the web and ask questions and get it. Now, if you write that, again, you are following a particular path. So you should write when to call that. But here the agent will decide when to call that or whether it should call it or not. Okay. So that's the shift in the behavior, the autonomous, behavior of the agents. So you have tools, you have a goal, you have a role, you have the tools. So then now you are an agent. So you have to do all of these things in a particular sequence or in a loop, right? There has to be a workflow to execute this, right? So to start here, do this, then do this. If this happens, go back, react, right? So all of this, the agent will execute using a few of the behavioral patterns, like it has memory, first thing, planning, action. So memory is like short-term, long-term memory you will have. I'll not dig deep into all of those attributes or features of the agent. We can just read up. So at a high level, so here you have understood, right? So autonomy operates with minimal human intervention. It initiates actions based on the context and goals. It learns and evolves in dynamic environments. So adaptability, that's the what's the agent. So we looked at this picture so many times from the RAG, we are saying. So now, so this is the classic RAG example where we have a LLM model here as the brain, but it's all a specific path, right? So you, based on the query, you go and search your library or your internal documentation that you have split and stored in as embeddings in the vector database. You get the relevant results, add those relevant results from your private information or organizational information, put it in the prompt and send it to LLM. So the LLM will refer to the query and refer to the context, which is actually the data that you have retrieved and sent it, and will try to answer that. So that's the typical retrieval augmented generation, the RAG application that we talked about. Now in this, there is only just one LLM. So it goes to the LLM, the LLM will give the response. That's done. There is no, it's like one shot. There's no loop. There is no action based or decision based There is no React architecture like reasoning and acting, right? So it's just you go to LLM, the LLM will give you the response. Now, when you put agent in the picture, right? So an agent, again, these pictures I've taken from web. So this is from the VV8, which is a vector database. Agent, if you see here, it has a brain, again, LLM, okay? And as we talked about, it has a task, whatever is the task. For in the example that we are discussing, we want to understand or get what is the latest performing stocks to invest in today. Okay, that's the task that we are giving the agent. So role we talked about, role is, we say, hey, you are a financial advisor. So you focus only on the content or information or knowledge related to the financial or stock market. Okay. Then we said it needs to have tools to execute. So there are various tools that you can do. So the first part, what we talked about is the RAG. That's what we have been talking about, discussing all through in our first 8 sessions, how we kind of put our information. Hey, the agent will decide, hey, do I have to um, answer from within my knowledge, whatever I have. Say, for example, I ask a question, what is the capital of France? So it does not need to go to vector database, calculator, web search, whatever it is, right? So it is a very general information. It has already been trained on, so it knows the answer and it'll answer it for you. So it doesn't need to go or call the tools. But how would you know? So that's the decision the agent is making autonomously. You are not telling the agent or writing the code somewhere, hey, if the answer is there, you do this. If it is not there, you call this tool. So that is the autonomous decision making. That's the whole, scenario. Okay. That's the whole purpose of having this, LLMs kind of intelligence to do the autonomous decision making. So it says Paris, right? Now, then I ask a question, hey, what is the maternity leave policy of my company? So it does not know what is your company. It does not know what is the maternity leave policy, because you are not going to publish your maternity policy on the internet or somebody so that all the agents can read that and be trained and ready to answer that, right? Unless, hey, if it is public information, that's fine. But if it's private information like HR, then it should make a decision that, hey, it does not have that knowledge, but I have some tools. Maybe I will go and look at these tools and see if I can use any of this tool to get that information. Now it can say, calculator and web search will not work for me. Gmail and Slack are just communication tools. So I think it's a vector database. I can go and check the collection and see if there is any information related to the maternity leave here. So it will call this RAG application tool that is connected to the collection, and the collection will give the response and it will send back. So that's the decision the agent should make. And that's one of the features, or that's one of the tests that you should make sure when you're building the agent, the evaluation. Is the tool calling, is the agent calling the right tool for the right question, right? So is it the tool calling is going proper, or I am asking for maternity leave and it is calling the calculator, right? So it's not getting response, it's getting an error. So in that case, there's an issue with the agent. It's not able to properly understand the question or decide to call the tool, which tool to call upon. Okay, so those are the tools that we have. Now we talked about memory, short term and long term. Short term memory is basically within the conversation. Just think of it as any of your programming you do, right? So you have declared variables, you have memory, RAM. As long as the program is running, all your variables, your temporary data calculations are all there in the memory. So you can always go back and refer as long as the application is running, as long as your program is running within the scope. Okay, so if there is a global variable, as long as the application is up, you can access that global variable from anywhere. You can do that. So that's the short-term memory. But once the application is going down, closed, or the job is run, completed, came out, then you don't have anything in the memory, right? So it's all flushed out. Next time when you run, it'll start from the scratch. But if you want to get the data, you always connect to the database and get it, right? So that is your long-term memory. So long-term memory is like whatever you're getting in the short term, whatever the calculations or intermediate records, template tables you're doing, you go and write to a database. In this case, it can be a vector database or it can be in-memory database that you want to store your conversations, you want to store your previous questions, chat, whatever information for the agent. So next time when you start a new conversation, it can always go and access that in-memory database to pull up that information, that memory, the state. You can write to a state or you can read from the state checkpoint memory. So that is your long-term memory. And then planning, you have to do all of this planning, right? So all I send you is only a question. So it has to plan, break down the task, what it needs to do. So in our example, if I say I want to do the best performing stocks based on the market analysis, so first it has to go to get a top 5 stocks based on the performance. It has to get their past history, and then it has to get what are the latest news about those 5 stocks, 10 stocks, whatever. What is the market conditions? What is the is it in general, how is the economy, or is it a good economy? Is it going to boom, bull market or bear market? All of that, it has to plan, right? And it has to execute in sequence. Okay. So all of that goes into the planning. So agent will plan, then it will break down the goal into smaller tasks. Then it will assign each task, or it can execute itself, or it can assign to other agents that we will see. And then use the tools to get, hey, first I go to Yahoo Finance, get the information. Then I will use that information, then go to web search, get news about those stocks. And then I will do the analysis. Then I will do summarization. So all of those steps, sequences, the agent will plan. So that is about planning, reflection and all of that. Reflection is like using the information or the history that it already has to summarize and use it for the context. Okay. So this is all the architecture of the agent. And then we also talked about you can have multiple agents. So that can be one agent can be just to retrieve the information. And once it has made the proper tool call and it came got the information, you can use the same thing in the loop again to do another task, or you can pass that to another LLM. So this will take all these results and summarize it for you. So this, router. So this can also be another agent. So as we see here, this is a multi-agent system. Now, if you see, it is all broken down to tasks based on what kind of tools or what kind of information is needed. So retrieval agent can ask a question, but then it knows which agent to pass to that question. Is it vector, or is it web or related, or is it communication related? So if it is internal information, it will call agent A, and the agent A will decide again based on the question, should it go to collection A, collection B? Basically, is it a HR related question or is it a finance related question? Assuming that your organization, you have created different collections and put the data of HR in this collection and finance in this collection, and that information is known. So the agent will make a decision to call which tool to call based on the question. Now, if it is a web related information, right? So let's say who won the IPL 2025, that kind of a question, or 24. So the agent will go to web search tool. So that agent will call the web search tool and provide the information. Similarly, if it is communication, it will do this and it will pass to the LLM to summarize and answer the question for us. So typically, this is how the multi-agentic or compound AI systems are built. It will always be like multiple agents. You don't want one agent, one LLM doing everything. So the quality will be very poor because it keeps doing the same thing. It will lose the context, right? So each agent doing a specific role will form, and these agents may have different roles to play. So this agent, as I said, might be we give a role that you are a web search agent. So it will only focus on web search, right? And this agent might be a RAG application. So you are a analyst, data analyst with this organization, and you have information about this organization. So that kind of roles, right? And here, like you are communication agent, we are communicating with the internal tools like Slack and Gmail to send or get information from. So each use multiple agents. Each agent will have a specific role to play. Okay, and those specific roles we give tools to use it. So in a nutshell, we're talking about what is an agent. So whenever user sends a request, the agent will have a brain. So this brain is your LLM. It'll have memory, it'll have tools, and it can do planning. So that's the very basic of your high level agentic framework. Okay. Any questions? Are you comfortable what we are talking about? Anything, you have doubts, questions, please.
So far, everything looks fine. So, to overcome with all the hallucination or all these things like RAG is the one solution. And I was reading the article over the weekend and the last few days. There's so many things like MCP and A2A, all those things are the solution, different approach with the multi
So
agent.
you are touching upon different things. Okay.
Okay. Okay.
So
Okay.
basically, this is the architecture of the agent, how the agent performs or executes an action. Okay. Now, hallucination is a generic topic, irrespective of an agent. It's for entire applications that you build, all the LLMs you have. So you need to handle the hallucination. Yes, RAG is one of the uh, techniques that you use to handle the hallucination. There are multiple things. Like one is your RAG application. The other one is your prompt engineering. You give specific system prompts, and memory, and you give directions. Another is guardrails. Most important one is guardrails. So you set guardrails where each input you are sending here, user request to the agent, before it goes to the agent, it goes through your guardrails. So they will check your input request and see if there is any malicious intent, malicious information. You're asking some illegal or anything forbidden questions. So that will it goes through all of those checks, the guardrails, and if there is anything, it will raise a flag and will stop here. If everything is good, then it will go here, do blah blah blah, all of this, and before it gets back to the user, it again flows through your guardrails, and then the guardrails will check, hey, the response I'm getting. So if the user is intelligent enough to jailbreak or trick the agent or LLM or guardrail to ask a question that is not appropriate, and then all of these agents and all of this have done and given you an answer. So in the response, again, it goes through the guardrails. So the guardrails will again check the response and see if the response or the information that you are about to share with the user is appropriate, or is there anything that needs to be filtered or stopped. So that is another guardrails. So all of these techniques are used to handle the hallucination of the LLMs and the security of the application. Okay. And the ones you talked about, MCP and A2A protocols, it's about how these agents communicate. Okay. So we are talking about, see here, this agent is talking to web search, right? So here, how is it talking? You're just making a library call, HTTP call or whatever, but there are new protocols that are coming up where this agent will talk using MCP protocol with the web search tool. So basically, if I am a what you call a travel agency, okay, and somebody is searching for somebody is searching for a travel package, okay, and I'm hotels.com, for example, and they are looking for hotels, so they can connect to hotels.com website or the application that I provide, I expose as a service from hotels.com, and then request information and get the information. So that part, connecting to an API or connecting to a service from hotels.com is how the new protocol, the agent will talk to the hotels.com service using the MCP protocol. So both the parties, like, you have to implement MCP, and the hotels.com would already provide a server that can, accept connections or requests using MCP protocol and respond to it. So that is the MCP protocol, how agents will talk to the tools or external tools or communicate with others. Right? So it's like currently we are doing API. So you're calling over HTTPS. Anybody who's exposing their API using microservices or any HTTP or HTTPS, any API they have exposed, REST APIs. So you're calling using HTTPS and you follow certain structure. What are the headers? What are the authentication you give, right? And it will go there. They take the request, authenticate, take your request, run the logic program, and give you the results, response. The same thing in the agentic world, it's coming up with the new standards across the industry, right? So everybody has to standardize. So that is coming up with MCP, Anthropic. Anthropic has created that model context protocol where agents can talk to the tools. The Google's A2A protocol is called agent to agent protocol. Basically, how these agents communicate with each other here. Okay, so agent A can talk to agent B can talk to C can talk to this. All these agents can communicate using the A2A protocol. So that's the protocol for the agents to communicate with each other. So that's different. That's the protocols, and hallucination security is different. Okay, but yeah, in the overall architecture, when you talk about building any GenAI applications, you should touch upon all of these. What is your RAG? What is your agent? What are the tools? What are the security? How would you handle security? It's very important. You should touch upon how would you handle hallucination? How would you evaluate your models? How would you control the security? And then how what protocols are used to communicate. So end to end, you can talk about all of this. All right.
So basically, we're talking about here how LLM thinks and take a plan and take action, like automation, intelligent workflow. That's what we're talking about, like think, action, and observation kind of. That's what we're
Yes.
talking. Okay, yeah.
Yes.
Okay.
Yeah. Absolutely.
Yeah.
Okay. So what are the frameworks? I will briefly touch upon. So I know today we have a lot of theory. Basically, yes, this is all very important to understand before we go and start, typing away our code. So agentic workflow or agentic AI. So what are the frameworks? LangChain, we have already been using to build RAG applications, right? So we take one step forward. We build a wrapper around LLM to make it a agent. Okay, so you can build agents in the LangChain as well, using the same framework, LangChain framework. LangFlow we have looked at, no code. You can drag and drop the components. So they will have a component called agent. So you can just drag and drop the agent, and then you configure all of those things. What tools you want to give the agent, what is its role, what is the prompt, all of that you can give to the agent. So LangGraph is another framework. We will discuss LangGraph, how to build multi-agent orchestration. So how you can build an agent and workflow using the LangGraph. Graph-based execution, it will do parallel workflows. Crew AI is another platform. It's very simple and beautiful. It's also not UI based. It's just a framework library. where you will have agents structured or organized, visualized as group. Okay, a team. You have a team lead, and then you have team, a manager, program manager, or a project manager kind of a thing. Then you have team leads, and then each team can do a leading one task, and they have their own tools to execute that. So it's structured like that. You build each agent, you build a crew, and then you get all of that together, and then you execute that crew. So Autogen is another platform basically for the conversational AI, again, AI-driven automation, basically this, Autogen to build multiple agents. Okay. Now, apart from this, these are like say frameworks, and so low code, no code. Apart from Langflow, we have seen Bedrock, right? So you can build agents on Bedrock. You can build on all the platforms, right? So in Databricks, you can build agents, agentic AI. You can build in Snowflake, you can build Cortex AI. In AWS, you can build using Amazon Lex, Amazon Flows, Bedrock, with agents. On Azure, you can build AI Foundry, where you have all of those agents. Google, you can build using Vertex AI. Okay, so there are so many platforms that you build. Apart from these big ones, there are some smaller applications, smaller platforms which are focused on automating the workflows for businesses, mostly, kind of say smaller businesses. And that is one specific very good feature, very good area to look at. I'll tell you something like make.ai. Okay. So they have automation workflows where you can choose any small business and implement that to automate their workflows. And then you have something called landing.ai for visual kind of I mean, your videos and audios, kind of using that inputs for automation. There are several others. N8N is one platform that you can use for automating workflows. See, apart from all big products, like you take Salesforce, you like Informatica, you take SnapLogic, you take whatever it is, they are all adding the AI capabilities, automation using AI. If you take Genie, Databricks, if anybody has worked on Databricks, they should be knowing Genie, AI BI Genie. Genie is completely based on compound AI. It's a conversational AI. So you don't see any LLMs, you don't see anything. It's all built on that architecture. You just get a UI. You can add your tables there, your database tables, and then you can start asking questions. So it will convert your text to SQL using these LLMs, and it will take context from the table descriptions, column descriptions, primary key, foreign keys. You define all that metadata, your examples, your instructions that you give. It uses all of that, generates a SQL on its own, and executes that SQL and gives you the result out. You can just type, say, hey, what is the sales of this store for the last 3 years? It will automatically convert that into a SQL. It knows what tables to access, what tables to join, to generate the SQL, execute that, and it'll get you that information. So that is all, again, compound AI systems. Okay. So why I touched upon these smaller platforms for you to look at is, let me show you this. So if you look at make.ai, okay. So see, basically, business full potential with makes intuitive no code development platform harness the full power of AI. Okay, so these are the smaller, lightweight, you can say, platforms to implement the to implement automate the workflows. So these are all built on AI, LLMs, and all of that in this part. So so you can accelerate innovation across all of these departments, implement the implement respond new market thanks 2000 plus pre-built applications. Okay, so they have 2000 plus pre-built apps on this platform. So it's a platform. Apps is basically just like your say workflow, automation workflow that you can use. Okay, can look at see connect anything. So if you want to connect any of these, LinkedIn, HubSpot, Claude, Canva, Intuit, so these are some of the more business models that are being built on the agentic AI. Okay, it's just like plug and play. There are so many workflows that you can use to connect to different applications to automate. Anyways, so that's about the what we are talking about the agentic AI. Okay. All right. So I hope you are all comfortable with the concept, and we can dig deeper, get into get our hands dirty with some code to look at. Okay. All set. All right. So first, I will start with what we want to do with the LLM tools, right? So what is agent, right? So we talked about this. So an agent is basically LLM with the tools, the autonomous decision making capability, and looping in the sense it's not just you go and get. You go get something, you evaluate, you reason, hey, is this enough? Does this answer the question? Have I reached the goal with this? Yes, you return to the user and provide. No, what next step? Next I have to act. So what is the next step I have to take? Then probably, hey, I'm not getting this information from RAG. Let me go to the web. Okay, so this is a mathematical problem. I don't need to go to the web. Let me call agent, or let me create my own functions. Okay, so that call the functions that are created as tools. So tools are, again, you have to understand a tool is not just something that is provided like Yahoo Finance or web search or whatever. You can write any Python function and then declare it as a tool, or create it as a tool and give it to an agent that as a tool. It's just like a function. Okay, so but you are not telling when to call the function. The agent will decide when to call the function, okay, if it has to call the function or not. So that's the main difference. Or you can in a SQL functions in a database, you can write a Python code to connect to a database, get the information data, and then give it as a tool, right? So tool can be anything that performs an action and gives a response that can be given to agent to execute. So here, first let me just some boilerplate code. So PyData is one framework library that we're talking about. So Yahoo Finance we talked about is a tool, OpenAI, DuckDuckGo search, LangChain, OpenAI, community. Arcsif and Wikipedia are two. Wikipedia, right? So it's another website. It's we can search Wikipedia using a tool. Arcsif is also the same thing, but it is more focused on research papers and all of that. So first I'll go and install this. I know some of you are working on the VS Code. I will also look at installing that and running. I don't want to make it too technical for people initially. Once you're comfortable with just online, without setup, you can run this directly. So then we will go and talk about more. I think I have somebody's chat. I've not yet taken OpenAI subscription with the API key. used Olama Gemma so far. Yeah, that's fine, Priya. You don't have to. Okay. If any LLM will work fine. So because you're not, at least for practice, all you have to know is instead of Olama, you can go use OpenAI with the key. If you have Gemma, if you have Gemma or if you have Grok, any of the LLMs free, you're fine to use it. The results may be different, but we are not focusing on that, so that should be fine. But some of the frameworks are specifically, OpenAI. If you need to do that, you need the keys. But otherwise, yes, you can use any of the framework, any of the LLMs. Okay, that should be fine. All right. So I'm just using again here OpenAI API key. That's fine. You can use any LLM for that. So here, LangChain core, I'm importing a function or object library called tool to create a tool and chat OpenAI. So how do you create a tool? As I said, you can create a Python function and then you can create a tool. So I'll say @tool and I'm creating a Python function. So this will become a declarative, right? So instead of in the LangChain core tools, so there are some declarative way of creating the tool. So you say @tool, and then you create your function. So multiply A, B, multiply two numbers. You're returning this as a string A star B because I'm returning the string here. So LLM equal to, I created a chat OpenAI, so all of these parameters optional that you can use, and what is the model that I'm using, GPT-4o mini. Okay. And here I'm binding this tools. So LLM has this chat OpenAI, this LLM object has a method called bind tools. So where I can just bind my tools to the LLM. Okay, this is the first step. Now let's run this. And see what happens when I do. Okay, now I have bind this multiply tool. It's the list, okay, because it's only one tool. So I use the same name of the function as the tool as multiply. Of course, I can also add another tool here at the rate to def add, and then I will use the same thing. Okay, I'll just say A plus B here. Add two numbers. And I will, so multiply, comma, I can give another add. Okay, so I have added two tools. One is to multiply, one is to add. So basically, again, generally, it can be anything. Okay, I'm just giving an example. It can be a calculator that you want to, to do any of these things. Now, with this LLM, so here LLM basic is just chat OpenAI. Now LLM with tools, I have already bind the tools with the LLM. So I'm using this LLM with tools and asking a question, what is the capital of India? Okay. Now you see here the content, the capital of India is New Delhi. So basically, if you look at this, right, as we discussed, we've been discussing the past 1 hour, LLM has the knowledge of this. It doesn't need to go take the help of any tool, execute any tool, call any tool to get this information, because LLM inheritedly, it has inherited that knowledge. It already has that knowledge. So it will use the already existing knowledge to answer this question. Now you can look at what are all the, so response is an object called AI message. There is a human message, there is a system message, there is a AI message. These are three different types of objects that you would see often when you do any of these agentic applications. So AI message. So you can see all of this metadata, token usage. It will tell you what are the tokens. Okay, completion to prompt tokens are 71. Total tokens are 80. Okay. And then so audio tokens, reasoning tokens, all of this information, it will print how much you have used for this particular LLM tools call. It's more like, tracing. When you integrate this with your tracing tools, observability tools that we will do later using, Langsmith. So you will see all that information is going there. Now, I'm asking this question. LLM with tools invoke, what is the result of 5 multiplied by 3? Okay. So now it's not the question that it has, okay, already. So it has to call some tools to understand. So it's a tool call. So here, see, here there is no tool call. Okay. Now here it says it understands it does not have that information. So it has to do a tool call. So additional, this has a tool calls function. It's in 2 arguments. Name is multiply. See, so this is the kind of autonomous decision making the agent will have. When to call, when to answer by yourself, or when to take help, when to call other tools. If I am going to take help, where I'm going, who am I asking to help? Okay, which tool, which function I need to call. So this says, hey, now you see your agent is working. It's not a complete agent yet. So that's what I'm saying. It's just I'm trying to add layer by layer so that you will understand from LLM to agent how it kind of transforms. So first layer LLM, I am just adding the tools as the first layer. Then planning, execution will all come later with the agent. LLM with tools, now I am just invoking. So ask this question, it has realized it does not have the knowledge like this to answer this question. It has to call the tool. Then it knows what are the tools it has. It has 2 tools, one multiply, one add. So even with that, it understands which it has to. So I have made it easier for it, because if you see here, I have used this word multiplied. So probably it is easier for the agent or for the LLM to understand, hey, this multiply should be this multiply. Again, I have some comments inside here. It will use these, okay, to understand which function it calls. The more information you provide here, the more easier it is. Otherwise, not to get overwhelmed or confused about which to call. Intelligence is all about based on information you provide. It will, the more information you provide, the more easier for the agent. The more context you provide, it is easier for the agent to understand and call the right function or do the right. Okay. Now, so same thing, I can also say, let's test. I have not done some. Let's say, and you must have observed, right? It is only showing the tool call. It is not showing the result output yet here. Okay. 8 added to 9. So if I run this, let's see what it does. What happened? LLM is confused. Okay, gotcha. Oh yeah, awesome. See, Again, there is a tool call. Maybe it took a long time to reason and act and all of that. Name is add. Okay, so it is calling the tool called add. So it understands because we have put some key items, keywords for it to understand. So added, we have put add here in the, it has to use the add. So somehow it kind of got things sorted out and understood, did the right tool call. Okay. If I just say, I have, okay, that's okay. So it might just go and use the LLM to do some calculations. But that's the kind of, how you see the LLM can make a decision to call the tools, available tools based on the query. So this query, it has not done tool call. This query, if it is multiply, it has used a multiply function. This query added, so it has one called a function called add. Now, we talked about the tools. We said, right? So Yahoo Finance, DuckDuck, Web Search, all of these, they all create to a kind of search APIs that can be used. So in the LangChain tools, they have created an implementation called DuckDuck Go Search Run, which is a web search tool. So you import DuckDuck Go Search, and then you create an object of this. And when you use it, it will go and search the web using this tool, DuckDuck Go Search. So now I am binding this tool, multiply. Add is also there. I can put add as well. Web search tool, DuckDuckGo search. I'm now binding this tool to this. I just added one more tool. So these are the ones I defined, just like, show you. You can define a tool in Python. These are the provided ones, implementations of various tools. So DuckDuckGo search is used to search the web. Now I have put the bind onto this. And the question I am asking now is, how is the weather today in Dallas? Okay. So if I use this, now again, you see there is a tool call. This is the query and the function name is DuckDuckGo search. So basically it is using the DuckDuckGo search tool. Okay. Since we already have all of these tools, now 1, 2, I've added one more tool. So, but based on the question, it was able to understand because we said today, it knows it does not have knowledge. It has to go to web, and then there is a tool for the web already available, and then it's calling the tool. So if let's see if I don't give this tool, okay, just for the sake of it, I just have only this tool. See, I don't have the real-time data access to provide current function. Isn't it beautiful? Right, guys? You can see how it immediately, changes or executes the information based on what it has. One second. Okay. Come on, guys. Answer. What? No reaction. Are you following?
Yeah, yeah. I have a quick question. If we
Uh-huh.
go a little up on there, let me. So the very first one we had simple AI assistant, like where is the capital of New Delhi? I mean, the
Mhm.
India is New Delhi. This is very simple assistant. So that information, the LLM has that information, so it gives you the result. And
Mhm.
the second, and then it has, so it had to go to you had to use this tool called multiplied, and it multiplied the answer, right? I mean, the answer was there. Is there?
No, the answer is still not there. It's just
Okay,
calling
okay.
that.
That's what I was looking. Okay, but it had okay. So information is not there, so he has to go to use the tool to get the answer.
So
It's still not
yes.
done yet. Yeah. Okay. Okay. Just okay.
Yeah, we'll
And
get
the
there. How to get the response? As I said, right?
okay. Yeah.
LLM
Yeah.
is only doing that, but it's not getting the response back. You have to kind of. It's not an agent yet. Okay. It's
Okay.
not a full-fledged agent. It's an LLM. As I said, we are going towards making it a full-fledged agent. We are adding whatever is needed. Okay. We are adding nuts and bolts, paints, everything to the engine to make it a car. Okay.
Yeah.
So right now it has engine, we put on wheels, it can just flow, but it does not have a body and paint and all of that, right? So uh, we're just adding one by one the components, step by step blocks, building blocks. So we had an LLM, we added the tools, we are able to see it is able to make a decision based on the question, whether to answer or whether to uh, call a tool, or which tool it has to call based on the question it has to answer, appropriate tool. Okay. And since it knows it's the weather, today does not have information, current weather information. So it cannot answer. It says, I don't have real time data access. This is one type of hallucination. Okay. It's not hallucination, it's handling. It is already handled because it's not trying to do some prediction, even though it does not have information. It says, I don't have information. That's a good thing, right? So that's handling the hallucination. But if I trick it, how is the weather in Dallas? If I just take today out, should do. Oh, I have added the web search tool here. So, okay, I'll remove the web search tool. I will just do how is the weather in Dallas. Real-time weather data. Okay. What is the weather like in Dallas in general? Let's see. Okay, see, great. Now I'm trying to tell the agent or LLM, hey, I'm not interested in current today. I'm just interested how is it like in general, which means now it knows, okay, you're not talking about the latest. So I can answer this with whatever information I have in general. So over the past, over the historical information that it has about the weather of Dallas, it can go through, read, summarize how it would be like in general in Dallas. Generally has a humid subtropical climate characterized by hot summers and mild winters. So what changed? What changed is how I asked the question, right? So what is the information that I'm asking for? So I have to make sure the LLM understands, or the LLM understands based on the question, whether is it something that it can answer or is it something that it does not have knowledge of, right? So that's the only thing. So the moment I changed the question, it kind of answered it in general, whatever the information it has. But if I be specific, the current or today, it says it has no information. But then if I add the tool again, it says, okay, I have the tool, it does the tool call. Okay, so those are the three things, right? So that makes it clear how the LLM is behaving based on the capabilities, tools, and based on the type of the question, right? All right, guys? Okay.
Arun, I have a question, sir. In this
Yeah.
scenario, where exactly it is searching in the web search and giving this answer, this general answer, or
No,
how?
it's from its own knowledge, right? There is no tool call here.
Yeah, it is not to call, but very, its own knowledge means like where exactly
It is the LLM,
it
right?
has that.
It is the
Is
LLM.
that
It has
open?
knowledge.
Okay, it has
Yeah,
already
OpenAI
existing
LLM,
knowledge.
right? So
Okay.
that's what we asked.
OpenAI. Okay, yeah, okay.
Here, see, where is the LLM? Yeah, see, LLM is
Mm.
chat OpenAI. This is the model, GPT-4
Okay.
Omni I am using. To
Mhm,
this
okay.
model, to this LLM, I am adding the tools, additional tools, this object. LLM with tools object has both LLM and the tools. So the LLM will understand, take decision. Okay. That's
So
what.
I think then if you add the web search tool also there, so it should give any different answer for this question, general question,
Depends
or
what it feels like. If it feels like using the tool, it will. If it does feels like it can answer, in general, it will. Let's see. We don't have control
Yeah.
over it, but we can influence, basic with prompts. No, it says it can. In general, it already has knowledge. I don't want to use the web search tool unless it is specific, which it cannot answer. Has some built-in ego
Mhm.
also, right? If I can answer, why would I take help? If I know, why would I take help? Kind of a thing. Okay.
Mhm.
Now, if I say, what is the weather like in Dallas at today? I'll just take this like also. Now it goes to dots. Just because you ask Dallas weather today, see, it has also rephrased your question to the tool call. You should observe that, right? It has not sent the exact same query. What is the weather in Dallas today? It just sent query Dallas weather today to DuckDuckGo search. Okay. Just by changing the query, now it goes to the tool. Now I am helpless. I have to take help. It goes and calls this tool.
Mm.
Okay. I know the answer is not back. That's where the next step that we are going. So at least we understand the decision making process, how the LLM
Yeah.
understands the query, how it takes a decision whether it has the knowledge, capability to answer it by itself. If it does not, it should take help. Do I have any tools? Yes, so I take help. So out of that, which tool I have to use to answer this question? So all of this we have demonstrated now. Okay, the capabilities of the LLM with the tools. Now comes, the planning, memory, execution, and all of that. So decision making we have seen. So this is all planning. So for that, so I have from the LangChain community, you have some libraries called tools and utilities. Okay. So you can look at the documentation, so boilerplate code, and I've commented out something. You can implement it as an assignment once I share this notebook with you. So here I'm implementing argzif API wrapper, argzif query run, Wikipedia API wrapper, and Wikipedia query run. Don't worry too much about what these are. It's a boilerplate code. The code is exactly the same how you'll use it, but query run, archive, Wikipedia, or in the tools. So these are the tools, and API wrapper on top of it, to facilitate and execute that. So basically, we are creating two tools here: one to connect to Wikipedia and one to connect to archive. So here we are only importing. So first you have to, install this archive and Wikipedia libraries, pip install. So once this is done, if you come down here, it's like, yeah. So once you install that, then you can import the wrapper from the utilities, and also from tools, you import these two. There are more like Yahoo Finance you're talking about, Google Serper. It's a tool that, from Google to search the web. Tavili is another one. It's very important. We'll use that in the coming sessions. For the memory we're talking about, right? So agent has a memory. So you have used something called conversation buffer memory. So you can add all of your conversation to the memory and it keeps referring to that memory. It builds up that chat conversation, and then it can answer based on the context any additional questions you have. So we'll dig into that later step by step. Okay. Now we are imported the tools. Now we are initializing the tools. So first we will create a wrapper. How many results? So top K results is basically when you search for something, how many results you want. Okay. From Arxif, when you search for a papers, how many results you want. Doc content characters. So how many maximum characters you want. So these are all parameters you can see here. What parameters it takes. Top K results. Max query length, continue on failure or no, maximum documents. So all of this general parameters you can look up. So Wikipedia, again, how many results you want, what is the maximum content characters, Wikipedia query run here, APA. Okay. Now when you create query run, so this is what is executable object. So this is what will actually run when you give execute and give the result, the two. And then you are providing this wrapper to it. Same thing here. So this is the boilerplate code. Whenever you want to use Arxiv or Wikipedia tool, you can just use this code here, importing, installing libraries, importing and creating the tools. Now, basically same thing here. So what I'm doing, I'm creating a list of the tools to pass. Okay. So multiply, web search tool, I have removed, for now commented out all of these, and only adding Arxiv and Wiki tool to this and binding these tools with the LLM. Okay. Now again, if I do the same thing, you will get there. See here, I have done 2 calls. Again, invoke, find me recent papers on large language models on Arxiv. Tell me the history of the internet using Wikipedia. So obviously we have given like hints, what to use. So it automatically, it uses the tools, corresponding tools, Arxiv and Wikipedia, to go and search for the information. Okay. Now, so again, we said here it's only the tool calling. So we are only looked at, it's calling the tools. Now, where is the response? So that's the next step. Okay. So we are almost at time. I will just quickly walk you through this. I have another, there is another framework that way I wanted to talk about, but I'll move it to tomorrow, the framework, so that, today you will go through this, understand all of this. Then tomorrow we'll continue. It will be similar tomorrow also, framework, building, using the Phi data or Agno framework, building the agents. So now we are going to agents. So here it's all LLM. We added tools to the LLM, binding the tools. And we looked at it is able to call the tools based on the question. Now we are talking about the agents, next step. So from LangChain agents, we are importing this class called create OpenAI tools agent. So this is the OpenAI. I am not sure if we can try with other LLM models, but it is the OpenAI tools agent, or maybe there are other tools agents also, which we'll see how it works. Can try that. Create OpenAI tools agent executor. So you're creating and you are executing the agent. And then you have a chat prompt template. So first I will define my query, whatever query here, and I will add it to the chat prompt template from messages. User, what is the user query is input. Okay. Placeholder, agent scratchpad. So agent scratchpad means where the agent will use just like a rough notebook to write interim results to refer to and see what it is doing, what it should do, temporary memory kind of a thing. We are giving it a scratchpad to keep the messages for conversational memory. You can add other messages for conversational memory. Now I'm creating a agent. So with the agent, what you need to have? I need to have an LLM. So that is my LLM. See here, this LLM is not LLM with bind tools. Okay. So without the tools, because the tools I'm giving it separately to the agent. So now I have to separate it out. I have to only give LLM and then I have to give tools. I have to give these two separately. I cannot mix it and give it. Okay. It will mix it itself whenever, whatever it wants to use. And the prompt template. So what I have created here. So when I execute, I have to pass the variable names that I have to give. So this is the input. This is the in Scratchpad. Now this is the agent I have created. I'm creating agent executor. In the executor, I will tell you what is the agent I have created. Again, I'm giving tools. I don't know why, but that's okay. So tools agent already has tools, but again, I'm in the executor, I'm passing the tools. Helps true, verbose true. It will tell you the tracing basically, how the agent is executing the steps. So I just used verbose true. And then I'm invoke. I'm invoking with input as this large language models on RCEF. Now let me run this and see what happens. Okay, see now invoking RCEF with query large language models. So it has rewritten this query. Okay, and sent this query to this tool RCEF. Okay, now see here the response. Now you can see the response. Now because this is a full-fledged completed agent. Okay, so invoking RCEF with query this, and then this is the published title, author, summary. This is what you get back. This is the published, this is published, this is published. So all of this. More papers or specific topics, please let me know. Finished chain. This is the input. This is the output. Based on what you have provided. The query agent. Okay. Now you can see if I kind of comment out this and say what do you want to search? Tell me about Apple from Wikipedia. Okay. I'm adding Wikipedia here because, as I said, right? If I just say, tell me about Apple, the LLM already has that information. So it might try to answer from itself. So I want it to invoke the tool call to Wikipedia search. I for just the example sake. There are different ways of doing it. So you can see how it behaves based on your question again. So I'm just trying to give it a hint by putting in Wikipedia here so that it will understand and try to invoke the corresponding tool call. Okay, so let me run this. Okay, see here, invoking Wikipedia with query Apple. Oh, see here. It's very interesting thing to understand about the context. When I said apple, it thought just an apple, right? So an apple is a round edible fruit produced by an apple tree. It's because Wikipedia has something about apple as a fruit as well. Fruit trees of the orchard or domestic apple, blah, 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 whatever, the entire history of the fruit as apple. Then invoking Wikipedia with query Apple Inc. It seems there was a mix-up and I retrieved information about the fruit apple instead of the company. let me try again to correct information about Apple Inc. See, now you see the workflow here, reasoning and act. So it reasoned based, it sent the query, got the response, then it reasoned, hey, is this the right thing? Did I get the right response? Should I send this back to the user? Now it reasoned, and then it realized that there was a mix-up. And then it said, I got the wrong answer. Let me try it again. So there is a loop. It reasoned, it acted, it went back to another call. So the second call is again made by the agent, okay, to the same tool again, but with different query here. See, the next time the query is Apple Inc. First time the query is Apple. Next time the query is Apple Inc. That's what, it thought that's what I'm interested in. So the second call, now it gave about the Apple Inc. Is an American multinational corporation, blah, 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 about the Apple company. Okay, so that's the chain. Now you see the beauty of how agent works. Fortunately, we got a very good example. Guys, come on, man. I'm so excited. You are not half excited as I am.
No, we're excited too. This is called instruction planning. Plan steps logically, kind of. That's the one I was reading, and this makes perfectly sense. Yeah.
Yeah. See, so it always excites me to see in action when something we thought theoretically, it's how it should behave, and when we see it is actually behaving that way, seeing it in action, right? So, yeah, very beautiful. I'm so happy that we got a very good example here to look at how the agents behave autonomously, how they act, how they choose, how they reason back when they get a response, and then decide again to try second time to fix it, to give you the proper answer, right? So beautiful, very, very nice. Think, act, reason, so that chain. All right. So with that note, I think we are at time. We'll wrap up today. So tomorrow we will do more agentic AI. We'll build more like this, same basically. And we will also try to see if we can get onto the no code platform. Basically, we'll see if we can execute that on the Langflow. But I think we should stick building agents first properly through this and understand how they are behaving. Okay. All right, guys. Any other questions before we wrap up today? All right. I hope you all had a very good session. Thank you so much. Appreciate you joining it today, and we will connect tomorrow again. Same time. Guys, thank you.
Yeah.
Thank you.
Thank you so much.
Thank you, guys. Take care. Bye.